We've now covered how to create files and directories, how to copy them, and how to move them as well. But there's one obvious operation which remains, and that is deleting. So to delete files from the command line, we can use rm, short for remove, as you may well guess, and we can then provide the name of the file that we want to delete as a single argument. So in this case, let's get rid of quotes.txt. We just took a copy of it and saved it as thesis/quotations.txt, so we don't need this copy anymore. If we run rm quotes.txt, run ls again, and we find indeed it has disappeared as expected. Much like cp, in order to delete a directory and its contents, we need to use the -r recursive option in order to delete a directory. So let's get rid of the thesis backup directory here. Another ls, let's run ls-f, and we will indeed see that the thesis backup directory is gone. So one important thing to bear in mind about running rm on the command line is that there is no recycle bin. So most graphical interfaces will provide you some sort of effectively an undo feature for deleting files, but that's not the case on the shell. This is one of the ways that reflects the fact that the shell is sort of this power environment where you can do a lot of stuff, but you're expected to know what you're doing and to mean it when you tell the computer to delete a file. So whilst it is in theory possible to recover files that have been deleted in this way, using software you can download off the internet, there's no guarantee that it will work. So far, we've been thinking about the shell as this sort of file navigator, and we've now sort of covered the basic sort of functionality that one expects from a program that you would use to navigate files. But we're now going to look at a feature which exemplifies why the shell is so powerful and ways in which it goes beyond what a graphical interface can do very easily. And so in particular, we're going to now look at using wildcards to perform actions or run commands with multiple files at the same time. To do this, we're going to work in the molecules directory. So let's just cd into that with cd molecules. And let's run an ls-f to see which files we have. So we have 6 files in here in what's called a PDB format, which is just a common format used to describe molecular structures. And we can write easily shell commands that work with all or just a subset of these files by using wildcards. Wildcards are essentially special characters which the shell will then use to match against the names of particular files. So to give you an example, let's use the ls command here with the -f option. And then let's use the wildcard star.pdb. What happens when we execute this command is that the shell, before it does anything else, it will look at any occurrences of wildcards, the asterisk in this case, and then it does what's called expanding the wildcard. So it will attempt to match the pattern described by this part of the command to any files or directories that it can. So in this case, the asterisk is able to stand in for any number of characters within a file name. So star.pdb should match all 6 of these file names because they all have some characters in front of .pdb. If we run this command, then indeed ls just returns the name of every file in the current directory. Let's look at a different example. If we were to extend this a bit, and add this thane in front of the .pdb. So our command now is the wildcard here is allowed to match any number of characters so long as it ends with thane.pdb. Looking at the files that we have in the current directory, we can see that there should be 2 files that match here, ethane and methane. Let's run the command and see if we get what we expect. Indeed we do. Ethane and methane are the only 2 that match. You don't just have to use wildcards at the beginning of a path, however, we can also use them in the middle. So for instance, if we were to say ls-fp *.pdb, again the asterisk can match any number of characters within a file name, so we're essentially looking for a file name that begins with P and ends in .pdb with anything in between. This should match pentane and propane, and indeed we see that it does. In addition to asterisk, there's one other commonly used wildcard, which is the question mark. To see how this works, let's run this example. ls-f question mark ethane.pdb. If we run this, what do we get? In this case, we only get methane.pdb. The difference between the asterisk and the question mark is that the question mark can match any one character, but there has to be at least one character. So the reason ethane.pdb is not matched by this wildcard is because there is no character that corresponds to the question mark, and therefore it does not match. If, however, we are to run ls-f asterisk ethane.pdb, then we get both ethane and methane.pdb. The asterisk here can match 0 or more characters, so there doesn't necessarily have to be any. You can use wildcards in combination with one another. For instance, if we run ls-f, then 3 question marks and ane.pdb, each of these question marks is going to attempt to match one character within the file name, and then the rest of the file name must just be ane.pdb. If we run this, then we only get 3 of the files. These are the ones where you only have 3 characters in front of ane.pdb. For instance, pentane with 4 characters in front of the ane.pdb does not match. One common sort of thing that is surprising when you use when you use wildcards, is what happens when you don't get a match. For instance, if I was to run ls-f star.pdf, when we don't have any files that end in star.pdf in the current directory, you get an error message in this case. What happens is that the shell looks at this line, goes to try and expand the wildcard first, but is unable to find any files that match, so it just passes the wildcard through to the ls command unchanged. In this case, we are specifically asking the ls command to list a single file called *.pdf. As this file does not exist in the current directory, ls fails, returning this error, no such file or directory.